Hello, seventh grade. Hopefully the video recording will work today. I think I figured out what was wrong with my computer sound, and so we should be good to go. All right, today is our last lesson for lesson 3. And so we're doing activity 3.3, Why Heat Rises. And if you can tell by our little picture, we're going to be explaining what happens to cause wind. Okay, so today is Wednesday, the 29th of April. Our agenda today is your bell work, this video lesson, and then you're going to be making a new model in your Science Interactive notebook on Google Classroom. Please turn in your assignments, and everything is due by the end of the day. So by the end of this lesson, you will understand how convection causes wind currents. All right. So questions for warm-up. So here are our other two models that we made. Okay, this was the first one you were supposed to do, and this was the second one. We're going to be doing a third one today. So how can understanding how air moves in the atmosphere help explain a storm? So take a second and think about it. How does understanding how air moves in the atmosphere explain what happens with a storm? Okay. And can we take our model of convection, so just our basic model of convection, this applies to, any kind of convection situation, and use it to explain atmosphere air. Okay, so here we have our first one, our first model where we explained how this all worked. And we had the sun sends down energy, and then the energy is absorbed by the Earth's surface. And then through the process of conduction, so that's when we transfer the energy, it transfers it into the air molecules, and that makes the air molecules warm. Okay. So can I use this model to explain? So we're going to look here. All right. Not sure what that's going on for, but all right. So how can these two models help us explain what's happening in the atmosphere? So here's the atmosphere, but there isn't anything on convection. Here's convection, but not anything in the atmosphere. So what we're going to do is we're going to take concepts from both of these models, and we're going to combine them to explain what makes convection currents in the atmosphere. Okay, so you are going to be needing to make a new model. Now you can make your model on the Google Slides with the art tools, or you can do what I did. I just did mine on a piece of paper, and then I took a picture and uploaded it into my slide. Okay, so this is going to go through what you're going to need to do with your model. So you can draw with me and pause it as you go, whatever you need to do. So I'm going to make it bigger, and then I'm going to stop talking up here because I'm ducking on here. Okay, so the first thing I'm going to do is I'm going to put in my horizon, my horizon line to stand for the Earth's surface. Because remember, in our other model, we had our sun as the heat source, and it was sending down solar energy, and it was converted to thermal energy. I'm not going to put the sun and those arrows down because that would just make our model a little bit more confusing. So what I'm going to do instead is I'm going to write that down in under the horizon part. So energy conversion colon is I'm going to take solar energy. So that's the light. Whoops, let's spell energy correctly. And it's going to convert into thermal energy. Okay, so this takes place of my sun and those arrows showing that energy transfer. Okay, now I'm going to label two places on my map down here on my Earth's surface. So this is going to be the cooler area. So I'm just going to put cooler spot. And this is going to be the warmer area. And you guys know me, I like color. So I'm doing it with my red. Warmer spot. Sport. Ugh. I'm not redoing that. Okay. So now we're going to put in that energy transfer from the thermal energy in the soil into the air. Okay. And remember we did. Okay. Important part. That is called conduction. When I take an energy source or a heat source and I'm transferring the energy, thermal energy, into the air, that is called conduction. Okay, let's go back. Did that with some arrows. So I'm just going to make some arrows every so often. Now, let's stop and think. If this spot is cooler, how much thermal energy is being transferred from the Earth as compared to this spot? How can I show that in my model? Well, easily, I can just add more arrows in the warmer spots. So I'm going to add some more arrows. Okay, so that more arrows is showing that there is more energy transfer going on. Okay, all right, let's go back to that. Oh, what'd I do? All right. No. Okay, so the first thing I'm going to do is I'm going to put in my horizon, just my horizon line to stand for the Earth's surface. About there? How can I show that in my model? Right. Well, yep, I'm going to show that by having more arrows in the warmer spots. So I'm going to add some more arrows. Okay, and that's going to show that this is much warmer because there's the arrows stand for that transfer of energy. Okay, and we'll have it taper down a little bit. Okay, so there's that part. So now I have my thermal energy transferring from the soil into the air. By conduction. Now, we're going to put in our hot air mass that's rising. So I'm going to use my red. Yes, I know it's pink, but my red marker disappeared. So we're going to put in the red arrow going up. Okay, and then over here, we're going to put the blue arrow coming down because it works like a cycle. Remember, it's a convection current. Okay, now I'm going to title up here on the top. And I'm going to use purple for me just because red and blue make purple because, you know, I'm weird. Okay, so I'm going to label this new one as convection in the atmosphere. Okay, there's one part that we didn't put on this model that we have put on other models, which was our molecules. Remember, hot air, the hotter the molecules are, the more thermal energy they have, the faster they move and the farther apart they move. So I'm going to space these molecules very far apart. As they start to get up here, they're going to get closer together because now they're cooling. They're becoming less dense, more dense and less buoyant. And so they're closer together because they have a higher density. Okay, so this is going to make this part falling and this part rising. Now, we can't have a vacuum in our atmosphere. Okay, it's just not made that way. So when the hot air rises, what's going to happen is it's going to pull this cold air over. And that, ladies and gentlemen, is what causes wind. Okay, so the first thing I'm going to do is I'm going to put in my... Okay, sorry. All right, so let's go over this a little bit more. So up here, I added to it and I put in my key. Whenever you have a model, you must put in a key. So I obviously have, it's labeled nicely. So I've got my blue arrow for the cooler air sinking, the red arrow for the warmer air rising. The green arrow is my wind. This is what causes wind, is when this down here rises and it pulls this over, it makes a wind. Okay. Dots are my air molecules, and the arrows stand for the transfer of thermal energy or conduction. Okay. All right. So your job is to go to your assignment. So I'm going to go to 4th hour right here. So your attendance question, and then there is something that says 429 assignment instructions. Okay. So the first instruction I'm going to show you is you go into here and you get your new slide. Okay, this one's orange for the background, so it's different than the last one. Make sure you've got all of them. Okay, and it's going to look similar if it will load. The internet's being really slow tonight. Okay, so here's your instructions. You can either, like I said before, either you can do this on a piece of paper like I did, or you can do it on your computer, whichever you prefer. And you're going to make the same model that we have for this. Okay, and throughout this whole unit, we're going to be adapting and adding to this model. So we're going to get really good at drawing it to understand how convection in the atmosphere works. So you're going to need to have a key, all of this stuff here. If you want to make it the exact same thing as mine, that's cool. If you want to make it a little bit more personal, that's fine. Okay. Whatever, as long as you have all of the same elements in it, I'm good with you having your own personal style with it. Okay, so you're going to put this into your own notebook. When you're done, you need to delete this page, or this. Sorry. Okay, when you are done, I don't want to see this page in your book. I want to see yours. Okay. One thing I would do if it were me is I would just add a slide. So let's pretend this is in your notebook. Add a slide, do your work on this slide. Then you can delete that when you're all the way done. So you don't lose the directions until you're all the way done. It's up to you how you want to do it. Okay. So after you put that in, your instructions gives you, it's pretty much the same thing as on the slide. Gives you all the directions that you need to do so. Okay. And I also put in a little bit bigger picture of the model. All right. Hope you guys are doing well. I did want to share one thing. So during the reading from earlier this week, when we talked about it, when the reading talked about how convection currents can cook your food, like when you cook a marshmallow over a fire, it's not the flames of the fire that's cooking it, it's the air that's heated in the convection cycle. One thing that we decided to try during one of the Zoom chats is I took one of those last big marshmallows I had and I actually put it in my air fryer on a piece of tinfoil, and it toasted it. It was just like it was toasted outside in over the fire. So I thought that was kind of funny. I thought I could share that with you guys. So that's all we've got for today. I hope you guys have a great day and a great night. If you have any questions, see me in the Zoom meeting, and I will talk to you guys later. Bye-bye.